Red Seal Exam Prep Review Explained number 2. Okay, before we get started, I want you to go into the description below and download the test, print it off, and fill in the test before I take it up in this video. Okay? Also, I'm keeping the comment section open, so if you have a disagreement or a complaint or a comment, throw it in there below and we'll see what happens. It might take me a while to answer back, but I will. Also, take a moment to please like and subscribe. It's free and it helps me out. Okay, let's get started right now. Question number 1. The largest square that can be machined from a 2.5-inch diameter piece of steel would be. Okay, let's draw a circle. So we have a circle that's 2.5-inch diameter. Let's draw a line from quadrant to quadrant. Okay, let's draw a line perpendicular from quadrant to quadrant again. Okay. Now let's divide 2.5 inches by 2. Come up with 1 1/4 inches. Therefore, each one of those legs is going to be 1 1/4 inches. Now let's draw a line from here to here, but all the way around in a square. Okay, so we know what these two lengths are, here and here. Let's do our trig to figure it out. So we need to know what the hypotenuse is. We can use trig, but let's use Pythagorean theorem. Okay, so a squared equals c squared plus b squared. Well, it's easy because c and b are the same, which is 1 1/4 inches. Okay, so let's square root those guys down. Let's add them together. Okay, so let's square root it to get rid of the a squared. Therefore, the largest square that can fit inside of a circle that's 2.5 inches is 1.767 inches. Question number 2. The feed rate for reaming a hole in a drill press should be blank that of drilling. Okay, so I had to look this up. According to my textbook, it's 2 to 3 times the feet of drilling, and it's 1 thou to 4 thou per flute per revolution. During my research, I also found a relatively good speeds and feeds calculator, this guy down here, and there's lots of different calculators with it. If you're in need for a calculator, look it up. It's not a bad calculator to use. Question 3. The time required to make 3 turning passes over a piece of stainless steel 8.5 inches long at 350 RPM and 6 thou feed. Approximate time in minutes. Okay, let's take a look. So 350 RPM and 6 thou per revolution. So it'll go approximately like this. So 350 times 6 thou. That's how far we can go in 1 minute. Divide that by 8.5. Therefore, each pass takes about 4 minutes. Now we're going to multiply that by 3, and we come up at around 12.1. Question 4. The resolution of a micrometer with a vernier scale is... Okay, so here's our thimble. Oh, what's resolution? Well, the resolution is the smallest amount that a micrometer or any other measuring instrument can measure. So since this has a vernier scale on it, which are these lines here, which these guys are representing over here, that means that they can measure, instead of 1 thou, they can measure 1/10. Question number 5. The micrometer spindle has blank threads per inch with a lead amount of travel in 1 revolution of blank inches. So let's take a look and see what we have here. So our spindle here has 25 thou on it. So every time it goes around, it counts 25 thou. So our lead or travel per revolution is going to be 25 thou. 1 inch divided by 25 thou is going to be 40. So therefore, there are 40 threads per inch. So the right answer for this one is going to be A. piece of steel is identified as 1070 steel in the SAE system of steel identification. What do the last two digits 70 represent? Over here, the last two digits represent the percentage of carbon content. Now, 70 is not 70%, it's actually 0.7%. Okay, question number 7. The best way to clean the filings from a file is to apply, well, certainly not solvent. Using a file card. Every time I go into the shop, I see students using the file card in an improper way. You grab onto the file card with your less dominant hand, you grab onto the file with your dominant hand, and you pull across the file in the same direction with the actual cut of the file. Which of the following tool is not used to start a manufacturer a hole? Well, let's take a look. We have a boring tool here, we have a twist drill here, a spade drill, and a spot drill. Now start a hole. Well, we can start a hole with a center drill, we can start a hole with a spade drill, we can start a hole with a drill, but we can't start a hole with a boring tool. We can finish a hole with a boring tool. Question number 9. The process of knurling. Okay, you got me. I had to include a trick question. You're like, Ray, what do you mean a trick question? Everyone knows that a knurling tool displaces metal with a relatively high pressure. Yes and no. Okay, let's take a look here. Wow, it does say that, Ray, just like we said. Okay, now that's forming knurling. Okay, there's also another type of knurling, which is cutting knurling. And this style here physically cuts chips out. So it's not actually going to make your diameter larger. So this one was a bit of a trick question. Question number 10. The top half of a die weighs 2,380 pounds. The hoist in the tool room is rated at 1 ton. Which of the following statement is correct? Okay. Before we get into correct statements, what is a ton? That seems kind of odd, doesn't it? So let's take a look. A ton is 2,000 pounds, which is basically what they're considering a short ton. Now you can also get what they call a metric ton, which is considered a long ton, which is 2,204 pounds. Either way, the weight of the top of the die exceeds the capacity of the hoist. You really need to not worry too much about the ton, but look at the actual weight rating. And if you're dealing with metric imperial weights, there's conversions, you need to check on those things. Now you turn around and you go, okay, well, whatever, it's a blank ton and we're dealing with metric or something along those lines. If it's only 1 ton, it's not a big deal. What happens when you're dealing with 45 ton? And yeah, there's tops of half of dies that way exceed 45 ton. So you do need to be careful with that. Question number 11. The diameter of a circle is 3.5 inches. The radius of that circle is blank. Dun, dun, dun. Okay. So you basically take your diameter, divide it by 2. So 3.5 divided by 2 is going to be 1 3/4. So therefore your answer is C, 1 3/4. Question number 12. A drill press operator can produce 20 parts in 15 minutes. How many parts can the operator produce in 2 hours? Okay, the trick to this question is knowing that there's 60 minutes in an hour, not 100. And 2 hours is going to have 120 minutes. So what we're going to do is we're going to create a ratio, 20 parts in 15 minutes, X amount of parts in 120 minutes. So therefore we're going to cross multiply 120 20 times 120 divided by 15 equals 160 parts. Therefore, you can produce 160 parts in 2 hours. Question number 13. The punch press produces 4 parts on each stroke. The work order states a rate of 16,400 parts per hour. The press must run at blank strokes per minute to meet the rate per hour. Okay. So we got 4 parts on each stroke. Each hour has 60 minutes in it. 1,600 parts per hour. 4 parts per each stroke. So it's 16,400 divided by 4 divided by 60 is 68.3 strokes per minute. Question number 14. Pinning refers to, you guessed it, filing. Pinning is an old name basically for chips or swarf, depending on what part of the country you're from. Question number 15. What feature of a thread is checked with a thread micrometer? The pitch diameter is checked with a thread micrometer. Question number 16. To indicate an angled surface and make that the surface is parallel to a surface plate, a machinist would use well, let's take a look at all the equipment. Angle plate and plate protractor, machinist vise, not really. V-block, if it was 45, yeah, I'd be all over the V-block thing because it's easiest to set up. So the winner needs to be a sign plate. So we'd set the indicator up and run across the top. The included angle of a lathe center measures 60 degrees. The reason why is because our center drills are 60 degrees as well. And that's why they're 60 degrees, so that they fit into our lathe centers. Question number 18. The grinding wheel identification is 32AR60-KV40. What number or letter represents the bond? So here's what it looks like on the actual wheel. And V represents the bond, which is vitrified. Question number 19. The grinding wheel identification is 32AR60-KV40. What number or letter represents the abrasive? Aluminum oxide, which is A. Okay, our last question. Question number 20. The grinding wheel identification is 32AR60-KV40. What number or letter represents the grain size? 60 is the grain size. Okay, what did you think of the video? Well, comments are open. Comment below. Also, if you enjoyed the video, even if you didn't, please like and subscribe. It's free. It'll help me out. Just click on the icon on my face and I'll do the rest. Also, don't forget, if you want to see other great videos, check out my YouTube channel, Shop in Math. Okay, have a good night. Thanks for watching.